Hello everyone and welcome back to the channel Airbus and what's it doing now. First of all, a warm welcome to all of the new subscribers to the channel. I've always maintained that I'm happy to do this. I really enjoy doing it, but clearly only if there's an appetite for it. And we've had over 101 subscribers to the channel in the last 28 days. Not 100, but 101, which is great to see, and I'm really encouraged by that. So clearly there is an appetite for it. You're obviously enjoying the content, so I'm happy to continue doing it. And thank you for the suggestions as well, and some of the comments that you guys have taken the time to feed back to me, and that really helps me, really helps the content to the channel as well. It also helps in understanding what your need is and what subjects you want to cover. So there's been some great suggestions so far, such as low visibility operations and procedures, which I'll look to cover in the future. Anti-icing was another subject which has been asked for, and I guess it's topical for this time of the year when we get flying, of course. It might not be topical because, of course, it might be summer before we even get near an airplane again, but who knows? Anyway, anti-icing is coming up as well. Performance was one of the other suggestions. So there's a few things coming up. Obviously, I've got a few things in the pipeline that I'm currently working on, but just to let you guys know that those suggestions are on the list, as it were. So I plan to take a look at one of those subjects is spoilers, because that will then nicely wrap up flight controls for us. And today we're going to take a look at the APU, because this will wrap up bleed and electrics as well. I know anti-ice is all part of the bleed system as well, so as I said, it is one of the subjects that I will cover, but I do mention the APU in electrics and bleed a fair bit, and I keep saying I'm going to come back to that in more detail later when we cover the APU system sort of exclusively, which is what we're going to do now. So the subjects to cover, this is a sort of typical format that I like to follow. We'll take a look at the overview of the APU, its system and components, the electrical and bleed management, the fire protection, overhead panel and the external panel. That's the panel outside by the ground power receptacle, little flap which opens up there to expose that panel to put the ground power in. So we take a little bit of a look at that, and we also have a look at abnormal operations, and where it says on the ECAM on single engine, if performance permits, cross bleed open. So we take a look at the conditions of where we might be able to do that and where we might not. So, okay, that's the intro. Let's get into it. Okay, so what I thought I'd do is get a schematic up on the board here, just to give you a brief basic overview of the system and components of the APU. This is a turbine engine, okay, and it's these are used for these sort of situations where there's to fit into tight spaces. So you see them on the sides of helicopters, and they fit nicely into the tail cone of the aircraft. So at the front here, you've got the load compressor. It's called that because it takes up most of the load. Attached to the front of it's a gearbox, and the gearbox then drives the APU generator, and then a bleed off then for the APU bleed via the APU bleed valve. And then you've got the sort of primary compressor here, and then the turbines. There's a pick-off up here, which is to prevent for surge protection, and that joins up to the APU bleed line. And then at the bottom here is the APU inlet flap. You'll see that as you walk around the aircraft, and before the APU is powered up, that's closed. And then as we start the power up process, that flap will electrically open from an electrical motor and allow the air to pass in to the load compressor. That's essentially it, and it is, largely very simple. It's all controlled from the ECB, which is the electrical control box. It's basically a simple FADEC as such, and it will control the bleed, and it will control the electrical generator, and it will control the RPM of the engine depending on the load. So quite simple, really, in its makeup. In terms of how it's powered, well, we'll talk about the electrical components and where it fits into the electrical system in a moment, and particularly when we come on to limitations. But essentially it's powered up from it started from the aircraft electrical system, ultimately via the batteries. It's fueled by the aircraft fuel tank system, and it's fueled on the left hand side. It's driven by, usually, from the aircraft's own fuel pumps. However, when they're not powered, such as for the first flight of the day, and there's no external ground power, then the APU will start and be fed from its own fuel pump, and that is via the AC essential or via the static inverter. So basically, as soon as you turn the batteries on, the batteries will then connect the static inverter, and then the APU pump will be able to run. So good, now that we have a sort of basic understanding that it will provide electrical generation for the aircraft, and we know that it will provide bleed source for the aircraft, and it's powered or it's fuel fed from the main fuel tanks, either via the fuel pumps themselves or its own fuel pump, it can provide electrical source for the aircraft of its entire system, both on the ground and in flight. So it's quite a powerful generator there, and I think the frequency hertz is very similar, if not identical. I guess it must be identical if it's going to get connected to the aircraft system. So as far as electrical generation is concerned, it's the same as what you'll find on the engine generators. So both in ground and in flight. And then bleed, again, it'll provide bleed for an engine start and also for our air conditioning. And as I mentioned earlier on, it'll start from either the aircraft batteries or from the aircraft's normal system. So let's just have a look and see how it attaches into both, or connects, I should say, into both the electrical system and into the bleed system. So just before we get on to bleed and pneumatic, it's probably a good idea to have a look at the limitations. So we know it can provide electrical sources for the aircraft in the air and on the ground, and bleed for our air conditioning, etc. But there are limitations associated with it. What I've also just noticed is that the sun's just come out behind my blind, and you can see a reflection of the window. Hopefully that's not affecting what you can see too much. Anyway, I'm just going to blot all that out in a minute with a nice picture of the limitations in the FCOM. So it can provide electrical sources to power the whole aircraft. It can provide bleed to power the aircraft as well via the bleed systems. But there are limitations to it. So just on the right hand side here, hopefully now I'll put a picture of the FCON limbs. And I think I'll probably use the 320 Neo. So the 1920 CEO Neo and 21 might differ slightly. So take a look at your own manuals for this in terms of its limitations. But you can see on here that provided the aircraft is powered normally, you can start the APU at any time. So let's say, for example, you suffered an engine failure in the cruise, then you have the APU available to you, but because the generators are powering both sides of the system, or one engine's generator is powering both sides of the system, you've then got normal power restored. You can then go ahead and start your APU. If, however, that's not the case and you don't have normal power restored to the aircraft, or you're in the EMA elect config, then the starting is limited to 25,000 feet. That, of course, is because with the air being that much thinner up there, it'll take much longer to start, and there's a chance you might drain the batteries. Whereas at a lower level there, you've got more successful start procedure. So 25, then you've got the start in the MO-elect config, and of course you can see there on the left-hand side with the yellow arrows the limitations of actually having just electrical power only, or electrical power and pneumatic bleed. There's limitations associated with that as well. So well worth just sort of getting your head around that and just remembering those figures, because when you are dealing with abnormal situation, particularly when we talked about abnormal electrical, which we talked about in the electrical briefing, then having a knowledge of when you can and can't start the APU would be really useful. Okay, so I'm going to come over to this side of the board now, so because I've drawn something up here for you. So I said we'd have a look at the electrical, or the electrical elements of the APU and its support for the electrical system, but there is a mnemonic which I'd like you to remember, and I covered this in electrics as well. It's a priority system, and it's on the mnemonic gear B, as I've put down here. So the aircraft electrical system wants to be powered by the aircraft generators first. That's the G. So with all else going on, whatever else is attached to the aircraft, if the generator running, that's what it wants. If, however, the generator isn't available, then the next available source will be the external ground power. After that would be the, I'll write this in here because it's more specific to the APU. The next available source it wants is the APU, followed by the RATs, and then followed by the batteries, and it's in that order of priority. So we can, let me just move this around a little bit because now I'm on this side of it. I'm sorry about this, I could have done this better. Looking at this in a practical way, okay, so if you're doing a one-engine taxi arrival procedure, coming back to stand, and you want to shut the engine down, the first thing you're going to do, of course, is start the APU. Once the APU comes online, the electrical control box is going to control all the functions of it, get it up to speed. That incidentally is going to either be 100% or 99%, depending on the demand. That's all controlled by the ECB. 1% apparently makes all the difference. And once that's online, you'll see it there in the electrical systems page. The APU is just sitting there running. Once it reaches frequency in hertz and the test is done, and then it's able to then join and power the electrical circuit for the aircraft. But notice, once that's available, you shut engine number 2 down because now there's no generator, there's no external power. The next available source on that side for AC bus 2 is the APU. The APU then comes online. Nice and simple. Think of it also now as if you're not going to do a single engine taxiing and you've got no APU and you taxi in on stand with both engines running, you'll signal to the ground staff there that you want external power plugged in. Once it's plugged in, you'll see it there on the SD page. Once it's within the defined limits, it'll then go green, and then you can press the external button. But it's attached to the aircraft, but because you've got both generators running, it won't attach. You have to physically do that, as you know, and then you've got the system powered by the ground power, and then you can shut it down. Yeah, so you kind of understand how that works. And exactly the same for the RAT as well. Next time you're in the simulator, in the cruise there, just put the RAT out on the electrical side. Put the RAT out. It will power the main hearts, which is the AC and DC essential. But AC bus 1 and bus 2 will still be powered by generator 1 and 2 if they are available. Good, and of course, lastly of all, then that's the battery. That's the least preferred source because, of course, you know, they can only power for a certain amount of time. So hopefully that kind of puts a little bit of meat on the bone in terms of priorities. The APU is in there, but it comes after the ground power and external power. Assuming that you didn't have any generators running, of course, it's sufficient enough to power all the electrical systems on the aircraft, and that's how we would power the aircraft up first flight of the day, isn't it, if you didn't have any ground power available to you. Good, okay, so let's have a look at bleed next. Okay, so the bleed then, I've just put down on the bottom left of the board here, and you'll have seen this diagram before when we were talking about pneumatics. The important thing to remember about the bleed, the APU bleed, remember it coming out the top here, comes into the bottom, connects into the system. It's to the left-hand side of the cross bleed, and I said cross bleed there, you impressed? Not cross feed. So it comes into the left-hand side of the cross bleed. So when we talk about abnormal, which we will at the end here, and we're looking at whether or not we can provide APU bleed to support the packs in the event of single engine operation, it's really important to know where this cross bleed, I'm pressing myself here, where the APU sits in reference to the cross bleed, because that's quite important when we're talking about abnormal lots. But essentially, it figures into the system on the left-hand side here. Your main sources here are obviously your engine 1 and 2 bleed, ground air source as well, and then the APU, as I say, fit into the left-hand side of the bleed. Okay, so let's take a look at the next topic. Okay, so the APU affords a similar fire protection to that of the main engines, in so much as it's managed by the FDU. So I've just drawn a very basic schematic here just to sort of help memorise it. And again, I apologise, the sun's just beaming on the front of the house now. It's coming in through my blinds, and it's now giving you a nice gold kind of post configuration out on my board, which is rather unhelpful, but hopefully you can still see it. So like I say, it's managed by the FDU, the Fire Detection Unit. Again, it's got 2 loops, a 2-loop system. I think somewhere I've got a picture of the fire loops, so if I have, I'll put it up here for you somewhere. again from my trip out to Malta, which you've obviously heard about in previous videos. So yeah, two elements there. It's only got one sensing area. I mean, the engines, which we'll come on to later on, have got several areas where they detect, hot spots in the engine that will give you a fire warning. But in the APU, there's only one. There's the one bottle with the 2 squibs as well. So it's protected by the fire detection unit, and if the aircraft is on the ground and the fire detecting unit sense that there's a fire, the APU will auto shut down, and it will also trigger both squibs of the fire extinguisher. On part of our walk around, of course, you'll check that disc is in place, the red disc up by the APU on the tail of the aircraft. That's to show that we want to check that's in place, so that the fire extinguisher is contained and that there's no overpressure. So when the fire detection unit detects a fire and the warning goes off, the APU shuts down, the extinguisher is ejected into the engine. You'll get a warning on the overhead panel, and also the ground crew will get a warning horn sound, which will come from the ground power receptacle hatch, and the panel there that I'll show you just on the right hand side here. So yeah, you'll get a warning in the flight deck on the overhead panel, and the horn will go off in that just by that receptacle. That panel itself, used by the ground crew. Have a look next time you're underneath the airplane. You can see the APU shut off. And you can see also the fire light as well, so that will go off. If the ground crew need to turn the APU off as an emergency shutdown or remote APU shut off, they'll literally just push that, and it's very similar to an emergency shutdown, only when it's done manually like that, there's no cooling cycle basically. That light comes on about 3 seconds or so after the fire has been detected. So essentially, warning horn in there, and the availability or the ability for ground crew or yourself to turn the APU off and emergency shut it down, basically, if so required. So let's have a brief look at the overhead panel then. So the overhead panel is pretty self-explanatory, I think. You've got the 2 buttons there, which is the master switch and the start switch. The master switch will basically power up the ECB and get the electrical source sort of via the batteries or via the electrical source of the aircraft powered to the ECB. And then when we press the start, the ECB then goes through the whole start process in commencing the start and stabilization of the APU, and then bringing it online so that it meets the requirements for the system to be brought online to the electrical load of the aircraft. Just one thing I will add on here, the start switch comes up when we talk about the, what was it, electrical? No, it was smoke, I believe, when we talked about the QRH smoke, avionics smoke checklist. And we spoke about the APU master switch very briefly when we were looking at evacuating the smoke. When the smoke becomes of greatest threat, go to smoke removal, and if you're on the MRLEC config, then you would press the APU master switch in order to have control of the outflow valve. So that's just reaffirmation that when you start the APU, that ultimately it's coming from the source of the power is ultimately coming from the batteries, even if it's indirectly coming from the main generation of the aircraft. So I don't want to complicate that too much, but that's essentially what's going on there. But I thought it was just worth mentioning that there, just to sort of reaffirm the power source of the APU in order to power the ECB. Right, okay, so I think some abnormal stuff now, so let's get on to that next. Before I rub this off and talk about abnormals, actually, I'm just going to stand aside a second, and then you can get a freeze frame of the board, so hopefully you kind of get a summation of everything that we've spoken about. Right, hopefully that's enough. Okay, so let's take a look at the very last bit of this briefing, which was the abnormals. I just want to have a look at some of the ECAMs you might get, first of all, from the APU, and some of the things that you may see or more commonly see, one of which is the oil low level. Now this only happens when you power up the APU and you press the start switch, the master switch. When you power up, oops, gone now, the ECB, but you'll remember that. Once you power up the ECB, it does a check, and if it's a low level, it'll pulse on the oil low level. Now it's okay to still start the APU, and it's okay to still run the APU. If you go to the QRH, I'll see if I can find an extract for you down here. It'll say to you, something in the region of able to run the APU for 10 hours. So that's not 10 hours of the day. What it means is the APU operation for 10 hours. And so even on a 4-sector day, you should be pretty safe with that. And certainly coming back to your home base, you'll want to let the engineers know before you go out again so that they can come and top the oil up, or it might be done overnight. So it's not a big event that, but just sort of let you know that it's got to a point where the time operation becomes limited. The other two that you might see is APU auto shutdown. Now, I think I said when we looked at the schematic overview of the APU, the inlet flap, and if that's not closed after a normal APU shutdown and it's in a position that it shouldn't be, quite often what you'll see, if that flap isn't where it should be because it wasn't shut down correctly by the previous crew, then you might get an APU auto shutdown. What I mean by that is sometimes when we come back to base, there's no external power available. So we shut the engines down, just before we're about to go, the APU goes off, everything then goes dark, and we wait to turn the batteries off for 2 minutes after the APU has done its check and it's run down, and then the APU flap then closes. If we turn the batteries off, remember it's the batteries that are powering the ECB at this point, then if that flap hasn't closed properly and we turn the batteries off, when it comes to the next crew the next day operating the APU, if that flap's not in the right position, that can lead to this APU auto shutdown. If you see the APU emergency shutdown, then that's a little bit more serious. So that triggers when the APU shut-off switch on the external power panel is pushed. So someone's pressed that downstairs, or the APU fire push button is pushed, or the APU fire on the ground is detected. So that's a little bit more serious. So that's when you want to get the ginger beers out to come and have a chat with. So I'm going to put my iPad down now because I think my arm's going to fall off. So having a look at some abnormal operations, sorry, hello again. Just having a look at some abnormal operations as far as the APU is concerned when we're dealing with engine failures, because this comes up quite often, obviously, when we come about recurrent checks and whether we should use the APU for the bleed. And it comes up as if performance permits, etc. APU bleed on. Right, so let's have a look at a simple case here. Let's have a look at engine number 2 has failed. So there's no bleed source out to the pack. The cross bleed valve is in auto, it's closed. Engine number 1 is feeding pack 1. Cross bleed is closed. Engine pack 2 pack valve is closed. It's no longer powered. So in this situation, it's really not much of a drama. We've still got one pack which will then power the air conditioning pack and the air conditioning for the aircraft, no problem whatsoever, and under normal conditions. What you will get on the ECAN though is that if performance permits, cross bleed open, and what that means is we open the cross bleed here. Get my little blue pen. And that will then power the other side. So now you've got a 2-pack operation. What it means by performance permits is if you're not concerned about performance, say for the go-around, you're not challenged by significant terrain, for example, and it's a fairly low level off, then you might want to consider having a 2-pack operation. It's not required, so you don't need to do it. But if you did, then it's available to you. Open the cross bleed, I nearly did it again, open the cross bleed, and then you've got a 2-pack operation. The only restriction to that is if you want to use wing anti-icing, then you'll have to turn one of the packs off. And of course the recommendation would be to turn the pack off on that on the associated sign with the engine failure. So that's pretty straightforward, I think. I'm just going to duck underneath here a second. Looking at a slightly more serious situation now, let's just say that engine 2 was had failed and it was damaged. If the engine is damaged and we've had to press a fire push button, then the cross bleed will always remain closed. And that's the important thing to remember here. We mustn't open the cross bleed when we've pressed a fire push button, because there is a risk then that we could contaminate the other pack with anything that might have been shoved down the bleed line from that destroyed engine. So there's a difference. With just a rundown, then you can open the cross bleed, but as soon as you've pressed the fire push button switch, then you can't use the cross bleed. That must remain closed, and that's why they talk about avoid icing conditions, because now, of course, you've got a situation with the cross bleed closed. You could have asymmetric wing anti-icing. Of course, we don't want that. We want, if there's going to be any icing build up, it needs to be uniformed along the wings, but ultimately we need to avoid that now. And there is a procedure that if icing is expected, then there's a V approach delta and configuration to think about, and that's all in your QRH. The only exception, well, there is no exception actually, because the cross bleed always remains closed, but where the APU comes into this, well, the electrical supply is not really important because we've spoken about that in the electrical systems, but in terms of bleed, which is what we're more concerned with here, if performance was still a consideration for you and you press the fire switch on engine number 2, because the APU is on the left hand side of the bleed system, you do have the ability to start the APU, well, you probably would have done that anyway in the engine out situation to provide power to the other side. But by maintaining the cross bleed closed, you could actually power pack number 1. And the reason you do that then is to give your engine a little bit more performance guarantee for a go around. Again, it's not required, but just for help you with your systems knowledge, that and it's only the case with engine number 2. You can't do it with engine number 1 because the APU is on that side, okay? And you must always maintain the cross bleed closed whenever you have a fire push button switch pressed. So if it's engine number 2, maintain it closed and you still have APU bleed to power pack 1 if you need to. Good, okay, I think that's basically all I have to talk about from the APU. I hope you enjoyed the presentation. I hope you got something from it. Please put any comments below for anything else that you want to see, or if you've got any questions about this particular briefing. If you liked it, please like it, and if you want to know when I produce other presentations and other briefs, then subscribe and then you'll get the notifications. Keep safe, keep the plate spinning, and I'll talk to you again soon. Thanks very much.